Hi guys, it's Miss Singh. In case you are wanting to revisit our talk on mapping Earth systems, this is it. So we are talking about maps in Chapter 2 and a whole bunch of different types of maps, but in general the definition of a map is a drawing of the Earth on a flat surface. I'm sure in history classes you've seen lots of different types of maps, some that look really old and the continents don't look quite like they are today. And now we have mapping technology where we can actually make maps using satellite images, so we're actually getting, the real images of the Earth. And it's a drawing of the Earth, which is a curved surface, and then putting it on a flat surface. And when that happens, something called distortion occurs. And as you can see in this image, Antarctica, which is usually fairly circular, has been stretched out into a long, skinny continent, and that is because of the distortion. We're taking something that was flat or that was round and now flattening it out. A globe, however, is a more accurate representation of the Earth because it shows all the shapes, sizes, and locations of the land masses and bodies of water more accurately. Unfortunately, it's not very convenient to carry around a globe, and globes don't give you a ton of detail, so we have to use maps, which are a little bit easier to transport and can provide us with details about cities and towns and roadways, etc. Whenever we are discussing direction on Earth, you're going to generally use reference points. That's when you pick a fixed place on the surface from which direction or location can be described, like either your latitude or longitude, like we're 77 degrees west longitude and 37 degrees north latitude. Or you can say, I live just northwest of Short Pump Town Center, or 3 doors down from a particular address. When you give your address, your full address with the, house number, roadway, city, town, and zip code, that is like the best reference point possible. But the more detail you can give, the better. So Short Pump Middle School is across the street from the gas station. That's not going to help anybody get there. But if you say Short Pump Middle School is across the street from the Valero and Fastmart, that's a little bit better. Somebody familiar with the area might know what you're talking about. Or if you say Short Pump Middle School is across from the Valero Fastmart in Glen Allen, Virginia, that'd probably help them find it on a map. If you say that Short Pump Middle School is across the street from the Fastmart Valero in Glen Allen, Virginia, which is a suburb of Richmond, Virginia, which is in the United States, they'd probably be able to figure out where you were at. Whenever we are discussing directions, we'll sometimes say things are north, south, east, or west of something else. Those are your cardinal directions. And then we will get the opportunity to play around with a magnetic compass. I know all of you probably have seen the compass on your cell phones before, but a magnetic compass, a handheld compass, is not powered by a battery. It is powered by Earth's magnetic field. The Earth has a magnetic field that's been created by the Earth's core, which is made of iron and nickel, and it sends energy around our planet, protecting us from solar radiation, and it keeps our atmosphere in place. These magnetic compasses use the Earth's magnetic field to point to magnetic north, which is the magnetic North Pole. And as I'm going to show you right here, magnetic north and magnetic south are different from geographic north and geographic south. Geographic north, as I say, is the place where Santa Claus lives. That is the point where the axis of the Earth is. That's the point on which the Earth rotates. And that is, in the middle of the Arctic Ocean, where the South Pole is on Antarctica. The magnetic North and South Pole are slightly off from those locations. Energy travels out of the South Pole and into the North Pole, creating that magnetic field. Your compass is going to be pointing to magnetic north, not to geographic north. Your cell phone might point to geographic north, but the compass, a handheld compass that uses the magnetic field, is going to be using finding the magnetic North Pole for you. So if you were to go hiking one day and you needed to head north towards the real North Pole, you actually need to adjust your compass a little bit. because it's pointing you to the magnetic north. And the change that you need to make is called the magnetic declination. It's an angle of correction needed to find true north. Richmond, Virginia has a declination of about 10 degrees to the west, which means you're going to need to adjust your compass reading about 10 degrees to the west. This is a map of magnetic declination from 2010. It's generally about the same as today as it was back then. As you can see, Richmond, Virginia has the -10 running through it. That means we need to adjust our handheld compasses 10 degrees to the west. This -5 means you need to adjust it to 5 degrees to the west, and then 6, 7, 8, 9, 10. So like if you were in Roanoke, for example, you only need to adjust it about 8 degrees. If you're out near Bristol, probably only 6 degrees. If you are on this black line, if you're on this black line here, you do not need to make any adjustment at all. And then anything in the blue, you are going to adjust that number of degrees to the east. I'm going to show you a quick little video from REI of a man talking about declination.
Hi, I'm Steve with the REI Outdoor School. I'm going to explain for you the concept of magnetic declination. It's important to understand when using a compass that the compass arrow points to magnetic north, not to the North Pole. In many parts of the world, this difference can be very great, 10, 15, or 20 degrees or more. You find your declination from your topographic map. It will give you a direction in degrees. When positioning the magnetic needle on your compass and taking a bearing, the goal is to align the magnetic needle with the orienting arrow on your dial. But because the magnetic north is different from true north, we have to align this needle with a point somewhere off of the north line. Your compass dial gives you a scale that gives you a point of reference for where magnetic north will be. When I align my compass, I'm going to make sure that the needle is pointed not to north, but to that declination degree.
All right, and now if I scroll down a little bit, you can see this is, again, from USGS. This one looks a little bit different because the 0 degree is now running through the panhandle of Florida, where mine in 2010 was running over through here a little bit. So just to show you here, if you lived in San Francisco, which is about 15 degrees to the east, or 14 degrees to the east, you would adjust your compass needle to about 14 degrees from the north on your compass. If you were in Pensacola, Florida, which is at that 0 mark, you just straight on, that's super easy. New York City, which is 14 degrees west, and it looks like Richmond is still around 10, maybe 9 degrees to the west. You would need to make sure you knock it a little bit this direction instead. So hopefully that makes sense to you. On maps, you're going to notice that there is a scale. A scale can look like any of these. Usually it's 1 inch equals so many miles or so many feet. Every single map will have a different scale. It just depends on how zoomed in or out you are from the true size of the location, and this is just a way for us to compare distances on a map to the real distances on Earth's surface. This would be helpful if you are in an area where there's no cell phone signals, you're not getting any GPS information maybe, and you need to figure out how many more miles you're going to need to travel on this road until you see civilization again. If it's, part of an inch, maybe it's only 10 miles. If it's a whole inch, it might be 13 miles. And if you notice, like, the entire country is going to have 1 inch is 1,400 miles. If you just have a part of the country, 1 inch can equal 585. If you're just looking at a state or a city, the scale is going to adjust. Meridians are lines that run north and south on a globe or map. The prime meridian is the 0 degree meridian line. It runs from the North Pole to the South Pole through Greenwich, England, and parts of France, parts of Spain, and then parts of the Horn of Africa. And that is a picture of the prime meridian marker in Greenwich. Lines of longitude are just another name for meridians. They measure degrees east and west of the prime meridian. Prime meridian is 0 again. So lines of longitude help us measure east and west of the prime meridian. If this is our prime meridian here, anything to the right is going to be in the eastern hemisphere. We live in the western hemisphere. Same for north and south. Time zones are going to be determined by lines of longitude. There's 24 time zones on the Earth's surface. That means somewhere on Earth it's every hour in a day. Every time zone is around 15 degrees, but as you can see, there are some countries that just choose to be all on the same time, like China. Almost all of Greenland is on the same time zone. There's the United States is subdivided into 4 time zones. We live in the eastern, the central, here, mountain, and Pacific. 2 states, Arizona and Indiana, do not participate with daylight savings time. So in the winter, Indiana is on East Coast time, but in the summer it is in central. Arizona is mountain in winter, and during the summer it is Pacific time. The international date line is the line on the other side of the planet from the prime meridian. So if you took that line and you went from the North Pole to the South Pole on the other side of the planet, it's 180 degrees. That is kind of the end mark of longitude measurement. If you are looking at the international date line and you head towards the eastern hemisphere, so if you're moving into the eastern hemisphere across the international date line, you subtract a day from your calendar. So like if it is Friday, I guess I shouldn't say you subtract a day. You are losing a day of your life, I should say. So if you leave LA and you are traveling to China, if you leave on a Friday, you will most definitely be arriving on a Saturday. If you left China on a Saturday at the right time, you could possibly be arriving in the United States on a Friday. So if you would get your day back if you head towards the Western Hemisphere across the international date line. Notice that the international date line is curved. It goes around the Aleutian Islands and around parts of Russia and around these Pacific Islands, and that is because we do not want one country split up into 2 days. Keep in mind that the United States and Canada are the last countries to experience anything on a day, while Russia, China, Australia, all the Asian nations are the first to experience something during the day. So these folks have already experienced Thursday, because today is Thursday, I'm saying this, and they are getting ready to start Friday. We are just wrapping up Thursday. Our Friday won't be happening for quite a few hours yet. Now, on a globe or map, you're also going to see lines running east and west, and those are called the parallel lines. They measure degrees north and south. The equator is the 0-degree parallel, and anything above the equator is degrees north latitude. Anything south of the equator is degrees south latitude. The North Pole and the South Pole are the 90-degree north or 90-degree south latitude marks. So the highest you can go for latitude is 90, but the highest you can go for longitude is 180 degrees, either east or west. The 180 plus 180 gives us 360, which is the entire spherical planet. Cartography is the study of making maps, and again, like I said before, when we are trying to represent a round surface and put it on a flat surface, things don't go well. And a map projection is the movement of an image from the curved surface to a flat surface. No map projection can correctly show features on Earth in correct proportions when you do that. So we have different methods of taking that curved surface and putting it onto a flat surface. That's called a projection. And we use these different projections depending on what we need to get right, because something's always going to be wrong with them. We just need to figure out which is the best projection to get the thing we are using this map for correct. Okay. The movement of a flat surface or a curved surface onto a flat surface is called projecting it, and there's always some distortion when we project. these are the three main types of map projections. You can either take a cylinder and project the image of the Earth onto that, then cut the cylinder open and you have a flat map. Azimuthal is if we take kind of a circular plane and we project the image of the Earth onto that. And then the conic is if we wrap a cone around the image of the Earth and then project the Earth onto that cone and then open the cone up and make it flat. A Mercator projection is a type of that cylindrical projection, as you see over here on the left. This is the main type that is used for navigation. What a cartographer will do, and a cartographer is someone who makes maps, they will make sure that the coastlines of continents are accurately shown, but what they cannot do is show land and water areas correctly. So a Mercator projection is going to be used for navigation, but it's mostly like if you're trying to get into a port. It's not going to be a good one to use if you're trying to figure out how long it's going to take you to cross the Atlantic Ocean. You're going to have to use a different projection for that. This is, I need to get into Boston Harbor. This is where I need to turn in order to do that, and where is the best location to dock. An equal area projection is a type of projection that makes sure that it shows the land the same size or as accurately as possible. You can make an equal area projection out of any of the methods, either cylindrical or conic or azimuthal. So the amount of land that is there is going to be accurate, but the shape of the continent might get distorted. You would use this if you are trying to hike or ride a bike or drive. You want to know how much land you're trying to cover. You don't care what it looks like. You just need to make sure you get from point A to point B and you have an accurate calculation of that distance. Types of equal area projections, like I said, azimuthal, you can do it like that. Conic, you can do it like that. With an azimuthal projection, you have one point of contact. Usually it's the North or South Pole, and that would be the most accurate location. But for example, if you put that circular plane on Richmond, Virginia, Richmond, Virginia would be the most accurate point on that map. And then the farther you go out from Richmond, Virginia, the more and more distortion would occur. So like, for example, Ashland and Petersburg would probably be pretty accurate. But if you go beyond that, maybe into Fredericksburg or South Hill or Virginia Beach or Charlottesville, those are farther away from the point of contact, which is Richmond, Virginia, so there's going to be more distortion. With a conic projection, again, the most accurate location is the point of contact, which is usually somewhere in the middle, and when we open up that cone, it kind of gets stretched out. So conic projections are best for mapping things that are wide. For example, the country United States is kind of wide, so a conic projection would be good for that. Tennessee is a wide state. Massachusetts is a wide state. Russia is a wide country. You would not want to use conic on Florida or New Hampshire, Vermont, because those are kind of long, skinny countries. California would be a bad one. Maybe Chile would be a bad place to map with conic. Only wide things for conic. And then again, this is azimuthal up here. Point of contact is always the most accurate the farther away you get from that point of contact. So the outer edge of the azimuthal is usually the least accurate location. On maps, you're always going to see a title, a compass rose. The title tells you the subject. The compass rose is going to show you north. The legend is going to give you any explanation of symbols. The scale is going to show you the distance between the surface, or the difference between surface and actual distance. And the date. The date's important because you need to know how old this map is. A map from 2000 short pump is going to be very, very different from 2015 short pump. There have been lots and lots of additions to this community since then. So you want to have a map that is correctly showing you all of the features, so it needs to be as up to date as possible. And I'm going to stop there because that's enough. And I will see you in class. Bye.